Hello, grade 7s, and welcome to a new unit of study in science, that being on heat and temperature. And in today's lesson, we are going to focus on different types of temperature scales, specifically the Celsius, Kelvin, and Fahrenheit scales. Learning outcome for today is to explain the operation of technological devices and systems that respond to temperature change. The two words that are bolded, technological devices, well, that would just be a reference to thermometers. A good starting point for this unit on heat and temperature would be to provide a definition of what temperature is. If I asked you right now to give a loose definition of what temperature is, you might say something along the lines of temperature is a description of how hot or cold something is. After we learn about the particle theory of matter, we're going to revise this definition to come up with something that's a little bit more scientific. It's not really scientific just to say temperature is a measure of how hot or cold something is. That's not tremendously specific. We can use our senses to determine the temperature of an object, whether it's hot or cold. The two senses I'm thinking of specifically is our sense of touch and our sense of sight. In our skin, we have some nerve endings that are sensitive to temperature changes. So, if we touch an object that's really cold or really hot, these nerve endings tell our brain that we need to remove our hand away just because of the extreme temperature. We can also use our sense of sight to identify how hot an object is. When objects reach a certain temperature, they start to glow and emit visible light in a bunch of different colors. Now, the colors we're going to focus on, we're going to look at the continuous spectra of light. Continuous spectra of light is what you would form if you took white light and you shone it through a glass prism, and it would break into the colors red, orange, yellow, green, blue, indigo, violet, the colors of the rainbow. And it turns out that if an object is glowing, an object that is violet and is glowing is at a greater temperature or is hotter than an object that emits red light. I think a lot of people might say that an object that's glowing red is the hottest temperature. And then usually when people say that, they think of something like lava, which has like that red or orange type color to it. If you're able to take that lava and increase its temperature even further, it would eventually start to emit yellow light, green light, blue light, violet light. So as the temperature goes up, you're going to get closer to that violet end of the spectrum. This is actually how astronomers can determine the temperature of different stars. If we had one star we observed that was emitting violet light compared to one star that was emitting green light, we would know that the star that's emitting violet light is at a greater temperature. So from red to violet in terms of objects glowing, red would be the lower temperature, violet would be the higher temperature. All right, so let's get into the temperature scales now, starting with the Celsius scale. The objective of the temperature scales is to give us very precise temperature readings. The Celsius scale is based on the properties of water, specifically. Seems like a good idea to base on the properties of water, considering how most of our planet is covered with water, and more specifically, the properties of water at sea level. At sea level, there is a certain atmospheric pressure, and as you start to go up from sea level, the atmospheric pressure starts to lower, which does have an effect on temperature, which we'll get into in the next lesson in this unit. The unit of measurement for the temperature for the Celsius scale is the degree Celsius. In a standard lab thermometer, we have a bunch of little tiny ticks on the glass, and each one of those ticks typically represents 1 degree Celsius. In terms of the properties of water and how this scale is based, well, the scale is constructed by looking at the melting point of ice, and basically we take the melting point of ice and we call it 0 degrees Celsius. we take the boiling point of water and we call that 100 degrees Celsius. So one way that you can actually calibrate a thermometer to create a Celsius scale is, for example, you might take the thermometer and you might put it in some like ice water. So I'll just draw ice water with a blue felt. Okay, so let's put it in like an ice water bath. That might make the colored alcohol in this thermometer go to, let's say, this level right here. So what we do is we would make a marking at that level and call it 0 degrees Celsius. Then we take that same thermometer and then we put it in now boiling hot water. So got a little steam coming out here. That's going to make the colored alcohol in the thermometer go up. And then maybe at the very top right here, we'd label this as 100 degrees Celsius. So we're basing 2 points on the thermometer on the melting point of ice and the boiling point of water. And then what we would do to fill in the rest of the thermometer is between 0 and 100, we just make 100 equally spaced markings where each one of those markings does represent a degree Celsius. Now, I just wanted to mention some common temperatures on the temperature Celsius scale that you should be familiar with. Comfortable room temperature is somewhere between 20, 25 degrees Celsius. 20 degrees Celsius, kind of like the lower end. If you're in a room at 20 degrees Celsius, it's comfortable, but it's a little bit cooler. 25 degrees Celsius, that's usually the temperature that you turn your thermostat up to, where your parents will start to yell at you that the temperature in the house is too warm. And it'd still be comfortable, but it's more on that warmer end. Healthy human body temperature is around 37 degrees Celsius. Regardless of like what the temperature is outside, your body has mechanisms that try to adjust to this. So for example, if the air temperature outside was 40 degrees Celsius, that'd be really, really hot. You probably have to go somewhere like close to the equator to get a temperature closer to that. Your body temperature doesn't match the temperature outside. What would happen is your body would sweat as a mechanism to cool down and keep the temperature around 37 degrees Celsius. In Calgary, like in the winter, the temperature outside might be negative 10 degrees Celsius. Well, my body temperature doesn't drop to negative 10 degrees Celsius. I have a mechanism again that tries to keep my body temperature close to 37 degrees. So what I would do is you'd shiver, burn some fat that would keep my temperature closer to that 37 degree mark. Now, it can change though. If you have a fever, then that temperature can be higher than 37 degrees. It could be like 39 degrees, kind of like 39 and a half, I suppose, is the area where you need to start worrying about having a fever. And if you had hypothermia where you were like extremely cold, I would expect that temperature to be a little bit lower. But otherwise, healthy human body has mechanisms that try to keep your body temperature around that number. Second one, the Kelvin scale. The Kelvin scale is based on the coldest possible temperature. So there is a limit in terms of how cold something can actually get. This coldest possible temperature is what we refer to as absolute zero. Absolute zero is theoretically equal to negative 273.15 degrees Celsius. The reason I've underlined the word theoretically is because that temperature has never actually been reached. There's mathematical models that theorize that is kind of like the limit in terms of how cold something could be, but we can't actually quite get to that number. So nothing can be at that number or below it. So negative 273.15 degrees Celsius, that's called absolute zero. That's the coldest theoretical possible temperature. The Kelvin scale is named after William Thomson, who I guess also went by the name of Lord Kelvin. He uses the Kelvin as the unit of temperature for the scale. Just one note here, we don't call it the degree Kelvin, just simply a Kelvin. The Kelvin scale starts at 0 Kelvin. So the starting point for the Kelvin scale is the lowest possible temperature. Well, that's about negative 273 degrees Celsius, absolute zero, a little bit above absolute zero. Just wanted to mention that even outer space does not have a temperature of absolute zero. The temperature of space is somewhere around 5 Kelvin, and it's due to some residual background radiation from the Big Bang. So we're at about 5 Kelvin. To calculate the Kelvin temperature, you take the Celsius temperature and you add 273. We can abbreviate that with some letters. We can say TK for your temperature Kelvin is equal to TC, which is your Celsius temperature, plus 273. So, for example, if we said the room temperature was 20 degrees Celsius, then the Kelvin temperature TK would be equal to 20 plus 273. So that would be equal to 293 Kelvin. So to go from Celsius to Kelvin, you add 273. This also works with the absolute zero temperature. So the absolute zero temperature would be, what's the absolute zero temperature in Celsius? Well, it's negative 273. Add 273, and that's equal to 0 Kelvin. So negative 273 degrees Celsius is 0 Kelvin. If we took this equation and just manipulated it a little bit, we could get another equation to calculate Celsius from Kelvin. So the temperature in Celsius would be equal to the temperature in Kelvin minus 273. So for example, if we want to figure out what the temperature in Celsius is in outer space, so we go the temperature in Celsius would be equal to, well, the Kelvin temperature is 5 Kelvin, subtract 273, so the temperature in outer space would be negative 268 degrees Celsius. So just a couple of equations that you can use to go from Celsius to Kelvin or from Kelvin to Celsius. To point out that the Kelvin scale, we don't use it really a whole lot in junior high. It's once you get into high school chemistry and you start talking about gases that a lot of the mathematical equations used for gases deal with temperature being in Kelvin. The last scale is one I just want you to be a little bit familiar with. I mean, it is common in the States. So in the United States, they use the Fahrenheit temperature scale to report their temperature in a city on like a daily basis. The Fahrenheit temperature scale is based on the freezing temperature of a solution of brine. Brine is a solution that has equal parts of ice, water, and a salt in it. The unit of measurement for the Fahrenheit temperature scale is the degree Fahrenheit, named after Daniel Gabriel Fahrenheit. The freezing temperature of brine is negative 32 degrees Celsius. So that's going to be kind of like our starting point, or at least a reference point for the Fahrenheit temperature scale. So brine freezes at negative 32 degrees Celsius, and we're going to call 0 degree Fahrenheit like our reference point for the Fahrenheit scale. To calculate the temperature in Fahrenheit, you take the temperature in Celsius, multiply by 1.8, and then add 32. Okay, so let's go through an example of how to do this. So I said, assuming room temperature is 21 degrees Celsius, I want to calculate this room temperature in degrees Fahrenheit. Now, when I show work for doing one of these mathematical equations, I like to use something called the 3-step procedure for showing work. And the way the 3-step procedure works is step 1, you write down the mathematical equation you're going to use. Step 2, you do a substitution of the letters for whatever numbers you want to plug in. So you pull out letters and plug numbers in, and then step 3 is just calculate the answer. Okay, so let's apply this for this calculation. So I want to calculate temperature in Fahrenheit. So my equation is the temperature in Fahrenheit is 1.8 times the temperature in Celsius plus 32. The temperature in Celsius is 21. So what I'm going to do is in the next step, I'm going to do a substitution. I'm going to pull this TC out and replace it with the 21. When I do that, I would then have 1.8 times 21 plus 32. Now, you could do that calculation in one step, but it's worth noting that you do need to follow the correct order of operations to do it, because the question is, what do you do first? Multiply 1.8 times 21 or go 21 plus 32? Well, think of the BEDMAS acronym that indicates the correct order of operation. Multiplication comes before addition, so we take care of the multiplication first. If we take care of their multiplication first, 1.8 times 21 is 37.8. And then we're just left with adding 32 to that. Therefore, 21 degrees Celsius would be a Fahrenheit temperature that is 69.8 degrees Fahrenheit. So your Fahrenheit temperatures are always going to be higher than your temperature in degrees Celsius. Okay, that's it for this lesson. I just want to make a note, when you do the assignment on temperature scales, any calculation question, use that 3-step procedure. So step 1, write the equation down. Step 2, do a substitution of the numbers in. Then step 3, write the answer with the correct units. And that includes doing any calculations with these 2 equations as well, the ones where you go from Celsius to Kelvin or from Kelvin to Celsius. Okay, and then I'll talk to you in the next lesson where we deal with the effect of pressure on temperature. And I'll talk to you then.